Today we're going to be looking at a problem that's on cable system. So you might notice that the drawing is a little bit different from what you have because I've already added the dotted lines so that you can see the difference between this triangle and that one on the right. So first things that I like to do is to go and write my components of whatever I have at the corners. So here I'm going to have my AY, then this side I'm going to have my EX. That side I'm going to have my DY, and going there I'm going to have my DX. So now first thing that I should do is to try and calculate these ones that are moving in the Y direction by using the sum of the moment at either A or B. Because if I want to find my dy, I'm going to take my sum of moment at A, and if I want to find my ay, I'm going to take some of my moments about D. So let's start with our sum of moment at A. So first thing that you have to do is to let whoever is marking your script know the direction that you're taking. So we're going to say we will let clockwise be positive. So clockwise, we know a normal clock moves in this direction. That's your clockwise. Then this, it's your anti. This is your anti, then this is your clockwise. So for us, anything that moves in clockwise is going to be considered positive. But I've made a separate video on moments and how you can calculate them. So we're going to start and say sum of the moment at A. What do we have? We can start with this one, the 500, that it's acting in this direction, which is going to be clockwise. We will have this 500 multiplied by the distance between this one and that one, which is going to be the 50 there. Then plus we have this 400 here multiplied by the distance between here to here, which is going to be 50 plus 50. It will give you your 100. Then plus we have this dy, which is going in this direction, which is going to be anti. So that one is going to be negative dy by the distance between here to there. It's your 150. Then you're going to equate this into 0. So we're going to get 25,000 plus 40,000 minus 150 dy. So we're going to say this one would be equals to your 65,000 minus 150 dy is equals to 0. Then you know your dy would be equals to 433.3 Newton. You see? So we've got that one. We can go and write it down that we have our 433.3 Newton. So since we've got that one and we have a limited space, I'm going to erase this one, and we can be able to find our AY also. So we're still going to do the same. We're calculating some of the moments around D in order to find our AY. We'll start with the same steps, then we'll say let our clockwise be positive. Then we'll say what sum of moment at D. What are we going to have? We have this one, which is moving in clockwise from here to there, which is going to be AY multiplied by the distance from here to there, which is 150. Then we have plus, we have this one which is going in that direction, which is a negative direction because it's anti-clockwise, by the 100, which is the distance between here to here, plus the 400, but this one is going in a negative direction. It's going to be negative by 50. Then this would be equals to 0. Then we have 150 AY minus 50,000 minus 50,000 minus that one is going to give us 20,000, then this will be equals to 0. We have 150 AY minus 70,000, this is equals to 0. Therefore your AY would be equals to, we have our 466.7 Newton. Then we go and say, okay, we have our 466.7 Newton. So since we're done with that one, we will also erase it to have space. So I just hope you are able to follow along as we are busy doing this. Then now comes the moment of truth, because now you have to make sure that everything is balanced. This is how you know that you are indeed doing the right calculation. So you have to confirm that sum of the forces that are going up is equals to sum of the forces that are going down. The ones that are going up, you have 466.7 plus 433.3. It's this one and this one. The ones going down is this one and this one. Then it's equals to your 500 plus your 400. Then the ones that are going up, it's 900. Then the ones that are going up, then the ones going down, I meant to say it's 900. So it now means that everything is balanced. So now we can go and try and do the other steps. The one that I just did was just to check if these things are balanced. You don't necessarily have to show it on your calculations. So now comes the step where you have to do your section. So with this step, you are basically going to be cutting a portion of your drawing. So my suggestion would be like to check a section that has most information, because now we have to either calculate our AX or our DX. So in order to calculate those ones, you look for a part or section that has most information. So if you can see, this triangle that you see here has most information, because now they've given you something like your HP and your 50 centimeters. So you can calculate the moments using those. But for the sake of this, we are going to be cutting this one here. You see, so if we're cutting that one here and we're taking some of the moments around B, what are we going to have? We're going to say, we start with the direction. We say we let our clockwise be positive. Then we say we've taken some of the moments around B. Then we will have what? We have our AY multiplied by that distance, which we're going to say we have 466.7 by 50 plus, then we have our AX. AX is moving in anti-clockwise, and we have this distance that is given here, which we're going to say we have minus AX multiplied by 10, then this is equals to 0. Then what are we going to have? We will have our 2333.5 minus 10 AX. This would be equals to 0. Okay, so it's like this. Then therefore our AX would be 2333.5, because you'll just like have to divide by the 10 when you take it to the other side. So now we've determined our AX, that our AX is 2333.5. Okay, so if you check at this problem, we only have two things that are acting within the horizontal axis. We have AX and DX. So if we were to take some of the forces in the X and we say, okay, what are we going to have? We're going to have minus AX plus our DX, then this would be equals to 0. Then we have minus 2333.5 plus our DX is equals to 0. Therefore, you can just say you have your DX is equals to your 2333.5 Newton. Remember, this is in Newton. So you can come also here and say this is your 2333.5 Newton. See, so you've done those parts. Then now what's next? So since you've found your AX and your AY, so how does this look like? So imagine if we were able to take out this triangle out. If I take this triangle out, I have a triangle that looks like this. So here I have my AB, then here I have my AX, which is my 2333.5, then my AY is going to be 466.7. These are in newtons. Then this side, what do I have? I have a triangle that looks like this. I have my CD, then my DY this side. Because remember, one thing that I want to explain is that these can be represented as a square. You have something that looks like this. Then here you have that line. Here you have that dy. Then that means even this side you can still take it as your dy. Then this side is your dx. This side is your dx. Same thing that I did this side. We have this square. I have my dy this side and dy that side. Hence, that's why I did something that looks like that. So now you will say your dx, it's what? It's your 2333.5. Then here you're going to say you have your 433.3. These are all in Newton. So now what you have to calculate is your AB and your CD, and you know you can calculate this using your Pythagoras theorem. You will say your AB is square root of, you have your 2333.5 all squared plus your 466.7 all squared. Then your AB is going to give you how much? It's 2380. You have your 2380. Then this side you have your CD will be equals to your square root of your 2333.5 all squared plus your 433.3 all squared. Then you get your how much for CD? You get your 2373. You have your 2373 Newton. This is in Newton. So now you can go and say, okay, here you have your 2373. You have your 2373. Then this side you have your 2380. 2380. So we're done with those ones. So now we can also be able to determine our HC, which is unknown. So how do we go about doing our HC? So the same concept that I was explaining with regards to your dx and your dy, you have something that looks like this. On this side you have your dy, you have your 433.3. Then this side you're going to have your 2333.5. you see. So now what do you have to do? You have to calculate this angle that you have here, because now we are trying to find the length in centimeters. So this angle, it's opposite to this, then this, it's your adjacent. So you're going to say your tan of theta is equals to your opposite over your adjacent, which is equals to your 433.3 divided by your 2333.5. Then your theta is equals to your arctan of your 433.3 divided by 2333.5. Then the angle will give you your 10.52 degrees. Okay, so since I have this angle here, it means now I can come again to the very same triangle and say I have something that looks like this. I have that 10.52. This side I have my 50 centimeter. Then this side is the HC that is unknown. Then how am I going to find my HC? Remember, as I said, this angle is opposite to this one. You're going to say you have your tan of 10.52 degrees is equals to your HC over your 50 centimeter. So your HC would be equals to your 50 multiplied by your tan of 10.52 degrees. Then this will give you how much? This will give you a value of 9.285. It's your 9.285 centimeter. So this one, we said it's your 9.2, let's just say 9.29. So we found that one. What's left, it's for us to find this BC that you see here. So how are we going to find BC? So with regards to our BC, you also have to be too careful with that one, because you need to use the fact of you know where the components are going to be like. So if I'm about to focus on this point C, what do I have? I have a force of 400 Newton that is going down. Then I have this one, which is my BC. Then you also can note that, as I said, at the top we do have a square that looks like this, and we also have this. So you have to interpret it in this way. I said I have my dy this side I can take it at ds dy. I have my dx and I have my dx. So with the BC that you see here, since we don't have it and we also don't know the angle inside, let me just call it beta. I will just call it beta. So since we don't have that angle, we can actually try and take BC into components. How do we take it into components? Taking it into components means now we are going to have what? We are going to have BCX, and this side we're going to be having our BCY. But on this one, I said our CD, we can just also take its component rather than having to work with this one, because we would actually have to determine this angle and still work backwards. So the safest way is to take this force that is going up, which is going to be that dy, and also take this one that is going that side, which is going to be that dx. But this we already found. We have that dx here, which we can just come and write it as your 2333.5. Then this one that is going up, we're going to say it's our 433.3 Newton. You see, so now what we have to do is to just calculate some of the forces in the x direction and some of the forces in the y direction. So we will start by saying, okay, some of the forces in the x direction, what do we have? We have this one, which is going to the left, because if you look at this one, it's a one that is going there, then this one is the one that is going up. But if we're going to write it in its component, we have the vertical component and the x component. So instead of having to take 2373, I just took it as this, because even if you were given an angle here and you try to work the components, you were still going to go back to this one, you see. So I will say I have my minus BCX. Let me just write it. It's a minus because it's going to the left, then plus your 2333.5. Then this would be equals to 0. Then if you solve this, you will see that your BCX is equals to your 2333.5 Newton. So you are done with some of the forces in the x direction. So you go to some of your forces in the y. We have this one that is going up, which is positive. We're going to say we have 433.3. Then we deduct the ones that are going down. We have what? We have 400. Then we have minus BCY. Then this would be equals to 433.3 minus 400. You are going to be left with 33.3 minus your BCY. Then this would be equals to 0. Your BCY would be equals to your 33.3 Newton. So now on this one, what are we having? We are having something that looks like this. We have BC here, then we have BCX. We said BCX is what? It's your 2333.5. This side, what do we have? We have our 33.3. Then if we want to find the actual BC, we will say our BC would be equals to your square root of what? Of your 2333.5 all squared plus your 33.3 all squared. See? Then now you determine that value, which is going to be 2334. Then you get your 2334 Newton. Then which means this one here, this one, which is your BC, you got your 2334 Newton. Remember, this one is Newton, this one is Newton. So it means now you were able to determine your HC and also the force in each and every cable. So the first step that you have to do, you write your dy and your ay at the end of this problem in the form of this. Then you find them. After finding them, you look for a triangle that has most information so that you can be able to find your ax. And you know, if you find your ax, since your ax is within the same line as your dx, you can even just conclude and say your dx will be equals to your ax. Then after finding those, you consider these triangles again, individual triangles with their dy and your dx, and be able to use Pythagoras theorem to find your CD and this side your AB. So after finding this one, you now come back again. I think there is one thing I forgot to mention, because this one was indeed at point C. This was at point C, but when we got to point C, what happened? We actually had to cut again here. So apology for that. We had to cut that side and interpret it in this way. We had B, this force which was going that side, and we also had that one that was going up. But in here, in order to work it nicely, we use the components like I did in order to find this answer here. But yeah, you will see in the question sometimes they tell you that you're going to be cutting somewhere in the middle, but you always do two cuts. You do the cut that is going to help you find your ax, and you do your cut that is also going to help you find your cable in the middle. So that's that. If you found this video useful, please like,